Hello, mindsetters. I hope you're all pumped up and ready because today it is a wonderful Monday. My name is Abraham, and I'm not alone. I'm here with Timlin.
Hi, how are you?
I'm fine, thanks, and yourself?
I'm good, thank you. I'm
Had
very
a
good.
great weekend?
Awesome weekend, yeah. Good Monday too, so it's all been good.
All right, if you had a bad weekend, we are still here to learn more and still do more. Today, we're talking about linear equations and quadratic equations. So I hope you all great hands are ready to learn more. Let me just tell you what, I'm looking forward for this session. I don't know about the viewers at home.
This is an awesome lesson because what we learned today is something that is going to be really important for the learners through to grade 11 and grade 12. So this is really fundamental stuff that is really important for the learners. So it's important that they get a good grasp on it.
All right, your last words to them to get ready before I push you away.
Get your pen, get your paper, get your calculator, sit down and let's get going.
All right, you had it all from Timlin. Get everything ready. Well, take it away,
so
go
much.
away. Right, while she goes and prepare for us, mindsetters, this is what you should be doing right now. Take your pen and paper next to you, as Timlin has said. Get on over Facebook. We are www.facebook.com/learnextra, or go to our website. We are at learnextra.co.za. Remember, guys, you can also download our notes for free for this lesson. We'll be having the link over the Facebook page. So get it rolling because we are here to help you. Your questions over the Facebook page. We'll be learning more. Timlin, take it away.
Thank you. Right, guys, as we said, this is a really, really important section. So it is crucial that you understand it. And if you don't, guys, make sure that you post those questions on Facebook. Either we're going to help you, or otherwise other mindsetters can help you. And let's just make sure that we understand this really well. Right, what we're going to be carrying on with today, we did start on it last week, is looking at linear equations. We're going to carry on with those, as well as quadratic equations, which becomes a really important part of our algebra. Right, let's get going and have a look at what our lesson description is all about. Today, as I mentioned, we're going to start with linear inequalities. So we're going to have a look at those and the methods that we use to solve a linear inequality. Then we're going to look at something quite interesting called a simultaneous equation. Now, a simultaneous equation, such an important concept, guys, and basically what we do there is we solve for not just one variable, we get to solve for two different variables, so it becomes quite interesting. Then we're going to have a look at solving our quadratic equations, okay? And we'll get into a more detailed description of how we actually go about doing those a bit later. And once we've done that, everybody's favorite, a little bit of problem solving. So let's get going and see what we've got with all of that. Okay, quickly to have a look at some key concepts, okay. Just to clarify, when we're talking about an inequality as opposed to an equation, just to bear in mind that an inequality is not just looking for one specific answer for x like an equation does. An inequality is saying if we're looking at one particular point on the number line, all the values for x are then everything either less than or greater than these points on the number line. So we're not just looking at one value for x, we get a whole range of values for x with an inequality, okay? With an inequality, please guys remember, we always represent it on a number line, okay? That is really important. With simultaneous equations, as I spoke to you earlier, we solve for the value of the x and the y, and I'm going to give you methods to do that in a minute. And finally, if we're looking at, the methods are just to, you can write these down just as notes, but we'll go over them in detail now. There's the elimination method and the substitution method, and those are the two different ways in which we can actually solve those simultaneous equations. Okay, right, so we're going to start with some inequalities, and let's have a look at this first example over here. With a linear inequality, it gets solved very similarly to a linear equation. Okay, there are one or two things we need to watch out for that do differ, and one of them obviously is that we're not working with an equal sign, we're working with a greater than or with a less than sign. Okay, just bear in mind very quickly, if we have a look over here, that symbol over there is our less than sign. All right, we've got our greater than. Then just something to watch out for. If I've got our less than and there's another little line underneath that, what that is saying is that it's less than and including, okay? So therefore this over here is your less than and equal to, or less than and including, which means that the possible values for x that you're solving for are going to actually include that particular value as well as all the values less than Or obviously the other way around would be if it's greater than or equal to. Just to remember that little line underneath it represents that it is also including that particular value. Okay, let's solve over here. So we've got 4, we're multiplying it by 2x minus 1. It is greater than 5x plus 2, and we have to solve the inequality. The first thing we are going to do is distribute our 4 into the bracket. So we are going to get 8x minus 4, which is greater than 5x plus 2. Okay, so what we need to do now, similar to an equation, we want to gather variables to the left-hand side, and we want to put all the constant terms, all the numbers on the right-hand side, okay? So the same process applies to as if it was an equation. My 5x is going to become negative 5x, and it's still greater than, my positive 2 stays positive 2 on the right-hand side, but my negative 4 became positive 4 when it came over. Right, so therefore what have I got? I've got 8 minus a 5, which is giving me a 3x, and I've got a 2 plus a 4, which is giving me 6. And just like an equation, we divide by 3 on each side, and we get to answer, well, we get an answer for x, well, a solution here, which is x is greater than 6, okay. Now remember, it's not just equal to 6, it is everything on our number line greater than 6. So therefore, we're going to put 6 on our number line. I'm going to represent it with an open dot, okay. The open dot, guys, remember, represents that it's not including. So basically on our number line, the values for x are everything greater than but not including 6. Okay. If, however, just to point it out, if there was a little line underneath there, what would then happen is that that dot would have to be a solid colored in dot. Okay, so an open dot represents not included. Solid dot represents included, okay? And just for now, I'm going to take that coloring in away, because just to write my answer in interval notation, we're going to say then that x is an element from. When it's not included with interval notation, we show a round bracket. When it is included, we represent it with a square bracket. That's what we do for included. Okay, but because 6 is not included, I'm going from 6, and it's going to positive infinity. And obviously, guys, there's never a point at which we actually include infinity, so therefore it's represented with a round bracket. Okay, there we go. So remember, with inequalities, you solve it very similarly to an equation. However, guys, when you get your answer, you represent it on a number line, and you show your answer in interval or set builder notation. Okay, either one of those would be acceptable unless they specified which one they wanted. Okay, all right, let's have a look. We've got another one over here to quickly go over. And we're going to go about it, like I've said before, like we would solve an equation. Okay, so let's have a look at what we've got here. This time I've got a fraction. I've got 2x minus 1 over 3 on the left-hand side, and I've got a 2x plus 1 on the right-hand side. Okay. Am I allowed to, if it's being divided by 3 on the left-hand side, could I bring this 3 up and multiply it on the right-hand side? Yes, I can. Okay, there's no problem with that. We can bring that up. So the next step we are going to have over here is to say that I've got 2x minus 1 is greater than or equal to, and now my 3 is going to distribute, and I'm going to have 6x plus 3. Okay, let's gather our x's to the left-hand side. So I'm going to say 2x minus 6x is greater than or equal to 3 plus 1. Okay, that's giving me a negative 4x, which is greater than or equal to 4. Right, now, grade 10s, are you all paying attention here? When we have an inequality and we divide by a negative, all right? So in this case over here, I am dividing by negative 4. What I do to the left-hand side, I do to the right-hand side. But what do you have to remember? This is what you need to remember, guys. I've got this sign over here, which was my greater than or equal to, because you are dividing by a negative, is going to turn around. It changes direction, guys, because therefore that gives you x is now less than or equal to negative 1. Please remember that. When you are dividing by a negative with an inequality, your sign must turn around. Okay, so many people forget to do that, and obviously it results in a wrong answer. So please be careful. Right, we're not done though. Remember, we need to represent it on a number line. So therefore, we are going to put our -1 on the number line. This time, because it's included, we're going to have a solid dot above our point, and x is less than or equal to -1. So on our number line, it's going to head down the number line, everything less than. As interval notation, we're going to say from -infinity all the way up to -1, which is included, is the solution there. Okay, right, so that's inequalities, guys. I think I've got one more example over here, which is a little bit of a variation on that. But so far, that's how we go about doing it. I hope you guys are all understanding that. If you're not, send us through some messages and we'll help you out there. Let's have a look at one more inequality quickly. This is also quite a common question, a common way in which we can ask it, okay? So what we said is that -8 is less than 3x minus 2, and that is less than 4. Okay, so now we've got this variable that's sandwiched between two other values, okay? And we've now got to find the value of the variable. All right, so what are we going to do? Let's take our -2. We know that we need to get x on its own, so we've got a -2. Now, if I were to bring -2 and I were to move it over to that side over there, it would become 8 plus 2, which is less than 3x. But now I have another side to it as well. So if I took my -2 and I moved it to this side, it would become less than 4 plus 2. Okay, all right, so that gives us -6, which is less than 3x, which is less than +6. And what would I do to get x on its own over here? We'd need to divide it by 3. So what we need to do on the one side, we need to do on the other side. All right, so those would cancel, leaving us with -2, which is less than x, which is less than +2. And on our number line, to represent it, we're going to have our -2 and we're going to have our +2. Both of the values are not included, so we've got open dots above each one of them, and then we are joining the line between it. So therefore, basically saying, guys, every possible value between negative and +2 will satisfy that inequality. It will make it true, okay? Anything on the other side of those two values would make it invalid. Okay. All right. And finally, let's quickly write it as interval notation. We've got -2 to +2, and they are all round brackets. Okay. Right, guys. So those are your inequalities. You need to please go and practice them. The key to remember is watch out for dividing by that negative. Your sign must turn around. Make sure you represent it on a number line, and also your interval notation. Included gets represented with your solid dot. It gets represented with a square bracket. Not included is your open dot and an interval notation with a round bracket. Okay. Right. I think for the moment we're going to take a short break, I'm sure, and we'll have give everyone a chance to catch their breath and get ready for some simultaneous equations afterwards.
So true, Tamlin. And talking about that, mindsetters, please get on the page. Remember, our Facebook page is just simple, facebook.com/learnextra, or go to our website. It is simple also. It is learnextra.co.za/live. Get your notes over there. We also have the fast link over the website and over the page. You can just get on the notes for free and also check out our schedules. But for now, let's take a quick commercial break, and we'll be back with more of your questions. As you keep on asking those questions over Facebook, we'll be tackling them right after the break. Do not move. Welcome back, guys. It's still another great edition of your Mathematics for Grade 10s. And I really like what I'm hearing now and what I'm seeing over the page. Guys, you really are paying attention. And Tamlin, there's just one question that I think we've made a mistake on, which is question 1.A. And everyone is just talking about that. Can you really correct that for us?
Absolutely. Sorry, guys. It was a silly mistake. So practice what I preach. Be careful with your working out, okay? 6 divided by 3, yes, it's 2. It's not 6. So watch out for that. Sorry, it was not 6. So go and correct your answer if that's what you wrote down.
Yes, and keep paying attention.
Yeah, and well done for correcting me, because yes, you are paying attention. So well done. Okay.
While still on that, Len, let me also tell you guys, if you're joining us for the first time, you're watching this show, it's great. And remember, you can get the notes over the website. It is learnextra.co.za/live, or go over Facebook. We are at facebook.com/learnextra. Keep those questions coming, because me and Tamla are here to help you.
Okay, right. Are we going to get going with our simultaneous equations? Right. Okay. These guys become super, super important when we work with many different aspects of our math syllabus. So whether it be trig, even geometry, these come up. Okay, so what they called are simultaneous equations. And basically the idea is that we are solving for two different variables of x and y. Okay, now first of all, let's put it into a picture for you as in terms of what we're actually doing here. If I had an equation such as this one over here, let's just call it equation 1. And I'm going to call this equation 2. Both equation 1 and equation 2 are linear equations, all right? So if I were to draw a graph and I were to plot two linear equations, okay, we're going to have to just quickly work out. Both of them would have, okay, this one over here would have a positive gradient. So the one would go more or less in that direction there. This is just a very rough picture of what we've got here. And the other one, let's say, is going in that direction over there. The point of a simultaneous equation is we're calculating the point where the two graphs crossed each other. And what we're doing is we're working out the x and the y coordinates at that point of intersection. Okay, that's what it's called, a point of intersection, where the two graphs cross each other. So that's what we're doing when we're solving a linear, a simultaneous equation. Okay, but we're not going to depend too much on the graph to determine the value of x and y, because a graph is not always an accurate indication of the diagram. So therefore what we're going to do is solve it algebraically. We're going to use algebra to solve it. Now, there are two different methods that we can go about using for simultaneous equations. So I'm going to show you both methods, and at the end of the day, you're going to work with the one that works for you. Okay. Right, the first method is called the elimination method. So elimination. And the second method is called the substitution method. Okay. Right, so we take our equations and we write them down, and as I've done, we label them equation 1 and equation 2. So I take 3x minus y was equal to 10, and that's equation 1, and I take x plus y equals 6, and that's equation 2. Okay, right, elimination method says look at your two equations and see if there are two variables that look the same, okay? That if I were to add the two equations together, would they cancel out, all right? So this is a good example of it, because if I look over here, I've got a negative y over there, and I've got a positive y over there. So this is the idea. If I took equation 1 and I added equation 2 to it, let's see what we would get. We would have 3y minus x equals 10, and I'm adding onto that my other equation of x minus y equals 6. Now, if we actually did that sum, 3 plus 1 is 4, so I've got my 4x over here, minus, that's a plus, minus y plus y eliminate. They cancel each other out. So that actually solved part of my problem, because now I've got rid of one of the variables that we were looking for. And I've got a 10 plus a 6, which gives us 16. Okay, so what we then are able to do is divide by 4, and we get an answer for x of 4. Okay, so if I know what the value for x is, then what we can do is find the value for y by taking this answer of x equals 4 and substituting it back into either equation 1 or equation 2. And guys, it doesn't matter. Okay? Probably the advice I would give you is choose the easier of the two equations, the less complicated of the two. It's just going to make your working out a bit simpler. So substitute that value of x equals 4. I would say equation 2 is our simpler one, so x plus y equals 6. So into equation 2. So therefore what we've got is x, which I now know is 4, plus y equals 6, and y is then equal to 6 minus 4, and that gives me 2. So what values have I got? I got a x value of 4 and a y value of 2. So what we're saying, if I go back to the diagram, is that if that was the point at which the two graphs intersected each other, obviously it's not 100% accurate, but the x value would be 4 and the y value would be 2. Okay, so that's the elimination method. Let's have a look at the substitution method. I've got 3x minus y is equal to 10. And again, we're still going to label that equation 1. And I've got x plus y equals 6. And we're still going to call that equation 2. Okay. We're going to look at the simpler of the two equations, which again, I think you guys agree would be equation 2. Okay. And in equation 2, what we want you to do is to isolate, so what I mean is get it on its own, either the x or the y. It doesn't matter. Again, choose the one that's easier to do. Okay. And I think just because it looks like it's going to work nicely for me, I'm going to get x on its own here. All right? So in order to do that, I'm going to say that I've got x is equal to 6 minus y. All right? And I'm going to call that equation 3 because I've now modified the equation. Okay? But this is now what we are going to do. If x is equal to 6 minus y, then what I'm going to do is I'm going to substitute my x, which is equal to 6 minus y, into, now the equation that we haven't used yet is equation 1. So we're going to substitute it into equation 1, all right? Which means that I've got a 3, instead of an x, I've got 6 minus y equals 10. Okay, let's solve that linear equation there. 3 times 6 is 18. I've got minus 3y minus another y equals 10. That's giving me negative 4y equals, I've got 10 minus 18, which is going to give us negative 8. And if we divide by 4 on either side, or negative 4, we land up with y equals 2. Let's double check ourselves. Do you guys agree we landed up with y equals 2 in the first method as well? So it doesn't matter about the method, you're getting the same answer, okay? And what did we do then? Once we've got an answer, we're going to substitute it back into. So y equals 2 into equation 1 or equation 2. Again, I still think equation 2 is the easier one, which means that I've got x plus, now instead of y, we've got the value of 2, which is equal to 6. And if I actually solve for x, I'm going to get 6 minus 2, which means we are going to get 4. So, guys, we still land up with the same x and y coordinate of 4 and 2 for each one. It was just a different route that we took. So we've got the elimination method or the substitution method. And again, it depends on what you guys are learning in class. If your teacher has shown you both and told you to choose the one that works best for you, great. If not, if you've learned one of the two methods, that's absolutely fine as well. Okay. All right. I've got another one here, which I do want to give a try to. And again, I'm going to quickly go through it in terms of the two different methods, just to make sure that you guys are clear on how they work. Okay, so let's divide our page in half again, just so that we have space to do both of our methods. All right, so first of all, we're going to start with our elimination. Okay, so as the name would suggest for elimination, you're wanting to try and get rid of or eliminate one of the variables. Right, I've got 2y minus 3x, which is equal to 7. That's going to be equation 1. And I have got 4y minus 5x, which is equal to 21. That's equation 2. Now, this one over here is a little bit more challenging than the one before, because the previous one, it was there in front of us. We had a plus y and we had a minus y, and we could see that they were going to cancel. This one's going to require a little bit more thinking. Okay, let's look at our variables. I've got a 2y and I've got a 4y. Now, in order for them to cancel, one of them would have to be a positive 4y, and the other would have to be a negative 4y. Okay, so therefore, what would I have to multiply this 2y by to get it to be negative 4y? I'd have to multiply it by a -2. All right? So let's show you over here. Now, this -2 basically distributes into the brackets. And it distributes to all the terms. So we land up with a -4y plus 2 times 3, which is 6x, and 7 times by -2, which is -14. Okay, so that's now this equation over here, which let's rename it equation 3. And we are going to add equation 1 to that. So I'm going to add my 4y minus 5x equals 21. All right, and hopefully what you guys can see from this is that now that I've done that, now that I multiplied the equation through by -2, I've got a minus 4y and a plus 4y that are going to eliminate. They cancel. I'm left with a positive 6x minus 5x, which is positive 1x, and I've got a -14 plus 21, which is going to leave us with just 7. Okay, so that's our value for x, and that's the hard part done. Once you've got one of the values, then it's a case of just subbing it back into either equation 1 or equation 2, and you'll get your answer for y. Okay, so which one do you want to sub it back into? So we're going to substitute our value of x equals 7 into equation, let's see what we've got here. We've got a 2y minus 3x equals 7. I've got a 4y minus 5x. I think this one over here is the easier one. Guys, I'm sure you agree with me. So 2y minus 3x equals 7. 2y minus 3x equals 7. Let's put that in there. So we've got a 2y minus 3x equals 7. That's going to give us -21 equals 7. We've got 2y, which is equal to, if that jumps over, we're going to land up with 28. So our y is equal to 14. Okay. All right, so the points, let's just quickly finish it off. The points then is that x is 7 and y is 14. Okay. Let's see if the substitution method gives us the same answer. I'm just going to write subs method just so we save some time. Okay. So remember the story now was that we had 2y minus 3x was equal to 7. I've got 4y minus 5x is equal to 21. Okay, you need to isolate or get on its own either the x or the y. Okay, here we need to be a little bit clever, guys, because otherwise we're going to land up with quite a complicated sum on our hands. Let's do the similar thing to what we did earlier. I'm going to actually multiply. I'm going to multiply this through by 2 again, okay? And the reason I'm doing that is because I'm going to land up having a 4y in both of my equations. So I'm going to have 4y minus 6x equals 14, and again we're going to rename that equation 3. Remember that was equation 1 and that was equation 2. Okay, so what I'm going to do in this equation, I'm going to get 4y on its own, which means I'm going to move 6x over, and I've got 6x plus 14. Now in equation 2, in this equation over here, I'm going to do the same thing. I'm going to rearrange it so that I can get 4y on its own. So therefore I'm going to say 4y is equal to positive 5x plus 21. All right? So let's look over here. Both of my equations have a 4y in it. Okay, so they're both equal to 4y. So if 4y is equal to 6x plus 14 and 4y is equal to 5x plus 21, then would we be able to say that 6x plus 14 is equal to 5x plus 21? And the answer to that is yes, we can. Okay. So when we bring 5 over, it's going to be 6 minus 5, which is going to leave us with 1x. And we are going to get a 21 minus a 14, and that's going to leave us with 7. Okay, so we've got x equals 7, which was the same as what we had on that side over there. And finally, I'm going to not do the working out because it's going to take a bit of time, but obviously we sub it back into either equation 1 or equation 2, and we get the answer. well worth your time to go and practice those, guys. It's really important to understand them, and it's important to get them right. So please go and practice them. Try both methods. Play with both of them and see which one works for you, okay? And at the end of the day, that's the one that's going to get you the right answer. So you've got to be comfortable with the method that you use, okay? Right, we are now going to have a look at quadratic equations. So before we do, guys, this is a whole new concept to start looking at. So before we do, I'm going to give you a chance to go and grab something to drink and just relax for a few seconds, and then we're going to get going with quadratic equations after that.
Actually, Tamlin, before we move to that, there's a question over Facebook from Sekhopi Monkwe saying, I really could not understand the difference between the signs. Can you go back a little bit, explain the signs, how do they differ?
The signs?
Yes.
Okay, I'm not sure exactly at what point we're referring to.
I think it's the first signs we did in the beginning.
Okay, we'll have to, I'm not actually 100% sure. I'd have to have a look at it and see where.
Let
me have a look at it during the break, and I'll see if I can actually answer that question for you, okay?
All right, while still on that, Mindsetters, go over the Facebook page. It is facebook.com/learn extra, or over our website for notes, schedules, so many stuff that you really, really need. It is learnextra.co.za. We are on the page to help you through. See you after the break. Don't move. Welcome back, Mindsetters. Hope you are ready now and revitalized, got some water, and you got your notes together over the Facebook page. Remember, we are here to help you and assist you guys. The Facebook page is facebook.com/learnextra, or over the website learnextra.co.za/live. Remember, guys, we're also having that question that we said Tamlin is going to get through. So are you ready to just fix that?
Yeah, like the question I think had to do with you were questioning why the sign turned from being a greater than to a less than sign. So we were going back to inequalities there. And if this is what you were asking, just to remember that by dividing, when does it change is when you're dividing by a negative. So that's when you've got to watch out for it, okay? So if you've got an inequality with either less than or greater than, doesn't matter. The point is if you're dividing by that negative, your sign turns around, okay? But the reason being because now everything is swung around. You're taking the negative from the left-hand side, and we're now putting it on the right-hand side. So everything has now changed direction. And that's the reason why you change that sign. So I hope that answers the question that you were asking for us.
I hope
and
so
let's
too.
have a look at what we've got with quadratic inequalities. Quadratic equations, okay. Right. What we need to first of all know is that when we're working with a quadratic equation, this is our standard form. ax squared plus bx plus c, okay? So any quadratic equation is going to be in that standard form as opposed to a linear, which is in your ax plus b form, okay? What's the difference? A linear equation will only ever be raised to the highest power of 1. So you'll only ever have an x to the power of 1, and as a result, you will only ever get one answer for x, okay? Because with a quadratic, you have got an x squared, all right? Your quadratic now will always have your highest exponent being an x squared, and you will now land up with 2 answers for x, okay? So that's the difference, guys. Linear, 1 answer. Quadratic, 2 answers. What's our method? How do we go about doing it? Right, the first thing is that once it is in our form, once we've identified it as a quadratic equation, we have to bring all the terms to the left-hand side. So everything has to be on the left-hand side, and the right-hand side must be equal to 0. That is a very big NB, guys. We've got to remember the right-hand side's got to be equal to 0. Once it's in that form, the next step is that we are then going to factorize the left-hand side. So whatever is on this side over here, it gets factorized. And we do that by the various different methods of factorizing. Highest common factor, difference of 2 squares, trinomial, whatever it is that's necessary, okay? And we again make sure the right-hand side is equal to 0. Once we've done that, we take each part of the factorized left-hand side. So I'm going to use an example over here. Let's say we've now factorized it, and I've got an x plus 2 and an x minus 2. We take each part of that factorized answer. So in other words, I take the first bracket, which is x plus 2, and I would make it equal to 0. As we've said over here, we make it equal to 0, and I would solve. And I would take the right-hand side, not the right-hand side, sorry, the other bracket of x minus 2, and I would make it equal to 0, and I would solve. So in terms of this particular little example, I would get 2 answers for x. One would be negative 2, and one would be positive 2. Okay, so guys, let's go over that again quickly. Quadratic equation, it's an x squared, all right? Once you've identified that, you bring all the terms to the left-hand side, and you make your right-hand side equal to 0. Once you've done that, you're going to factorize your left-hand side, all right? And once it is factorized, we take each part of your factorized answer, and you make it equal to 0. And you solve for x, okay? And we land up then with, if it's x squared, we land up with those 2 answers for x. So let's practice some. Okay, I have got 9x squared minus 6x minus 8 is equal to 0. So step number 1, in fact, is already done for us because everything is already on the left-hand side. The right-hand side is already equal to 0. So that's done. Now we have to factorize the left-hand side. Now this brings into it a little bit of factorizing that we had to learn this year, where there's a value, where there's a coefficient in front of our x squared, and then you've got your number at the back, okay? Now a method that I use in class, but you know, there's all different ways of doing things, so if you have learned a different method in order to factorize this, that's fine. I'm just going to use the method that I normally use, okay? To factorize this trinomial, I need to take the factors of 9, which is either 9 times 1 or 3 times 3. And then I'm going to take the factors of 8, which is either 8 times 1 or 4 times 2. Now in this method, just one side of this line over here, only one side of your factors, needs to be inverted. So in other words, I'm going to make it 1 and 8, 2 and 4. And the reason for that is we're trying to cover all the different possible combination of factors. Okay. We are looking for a negative 6 in the middle over here. So we're trying to find a combination that is going to get us to a 6. All right, so let's see what we've got here. If I have got a 3 times a 2, 3 times 2 is 6, and 3 times 4 is 12. Now, if I took that 6 as a positive and that 12 as a negative, I would get an answer of negative 6, which is exactly what you are looking for in the middle. Okay, so therefore we put a bracket around the first combination and a bracket around the bottom combination. And that's what my factorized brackets are going to look like. I'm going to have a 3 and a 4. There's my 3 and there's my 4. And I'm going to have a 3 from there and a 2 from there. X and X. Okay, as far as signs go, remember the 6 needed to be positive, the 12 needed to be negative. So if I do my inners, 3 times 4 gave me 12, so that needed to be negative and that positive. Okay, that's also a method you guys must practice. You must get used to that. Right, so now that I've factorized the left-hand side, now what we're going to do is we're going to take each bracket, so 3x minus 4, and I'm going to make it equal to 0. Or I'm going to take the other bracket, which is 3x plus 2, and I'm going to make it equal to 0. And then I'm going to solve. Now what's happened is we've created 2 linear equations, okay? So we've gone from quadratic down to linear, and now we can solve them. So we can say that 3x is equal to 4, so x is equal to 4 over 3. Or I've got 3x is equal to negative 2, so x is equal to negative 2 over 3. All right, guys, and that is how we solve a quadratic equation. Okay, this over here is an important method, and as I said, it's not that you necessarily need to use the method that I've just used, but whatever the method is that you guys have used or learned to factorize a trinomial where there's a number in the front and a number at the back, practice it, okay? It can become a huge problem later on when you struggle to factorize those trinomials. It's worth the time to practice them. Okay, guys, let's give another one a try. Okay, once again, the setters of this question have been nice to us because over here I've already got my one side equal to 0, all right? It's the other way round. The right-hand side is equal to all the values and the left-hand side is equal to naught. If it makes you feel better, if it looks better to you, you can swap them around, okay? So we could write this as negative 2x squared plus 4x minus 2 equals 0. Okay, so we can do that. Right, what is the first thing we learned how to do when we were factorizing? And that was to take out a highest common factor, okay? So that's what you guys are going to do here. I can see that I have got a common factor of negative 2 that can come out. That's going to leave you with an x squared. It's going to leave me with a negative 2x, and it's going to leave me with a positive 1 is equal to 0, okay? Because this side is equal to 0, guys, we are allowed to, that negative 2 will fall away. Because if I take anything, naught divided by anything, it will always stay just 0. Okay, so having done that, we now factorize the left-hand side. So I'm going to get x and x. I'm going to have to use 1 and 1. Both of them will be negative. And here I've got a doubled answer. I've got x is equal to 1 or x is equal to 1. So that's fine. It just means that my two values are going to be equal to each other there. Okay, there we go. I hope you guys are getting the hang of this. So let's see if we've got another one to practice here. Okay, here we've got a little bit of a different equation. It might land up being quadratic. We're not sure just yet, but it does have fractions. Okay, so let's see what we're going to do with it over here. When you are adding and subtracting fractions, guys, fact of the matter is, no matter whether it's algebraic or whether there's numbers there, we have to find a lowest common denominator. Okay, so in this example over here, I've got a 3a minus 4, I've got a 2a plus 5, and I've got another 2a plus 5. So what is my LCD going to be? I'm going to have to include the bracket of 3a minus 4, so we're going to include that bracket over there. And I'm going to have to include the bracket of 2a plus 5, but that then covers both of those denominators, so we don't have to write it twice. Okay, so we are going to put everything over the LCD, and we're going to have to do it on the left-hand side and on the right-hand side of my equation. So we've got our 3a minus 4, and I've got my 2a plus 5, and same thing on this side, 3a minus 4 and 2a plus 5. Okay, right, this numerator, that was over, that a plus 1 was only over 3a minus 4, which means we need to multiply it by 2a plus 5. This 9 was only over 2a plus 5, so therefore we need to multiply it by 3a minus 4. And in fact, we definitely need to give ourselves more space here. So I'm just going to take that off for now, in fact. Let's get rid of this line here. Let's just delete that. Okay. So that's going to be equal. Wait a minute. So there we go. We're going to extend that line over there. And this 2a plus 3 was over the 2a plus 5. So therefore, what it's missing is the 3a minus 4. And it's equal to 0. Okay. Right, at this point, if you've got an equation that we are solving for x, or for a in this case, and you've got a denominator, you can drop the denominator, okay? But we have mentioned in the past, if the denominator has got a variable in it, there's the potential for a restriction, okay? And a restriction is basically that my denominator cannot be equal to 0. So whatever my a value is in that first bracket, it cannot make my denominator equal to 0. And whatever my a is in that denominator over there, or that bracket, it can't make the denominator equal to 0. So point being, once we have actually got our answers for x, we need to just sub them back into the denominator and make sure that we don't get 0 in the denominator. Okay. All right, so now we've got a whole lot of FOIL to do. So let's times these out and see what we've got, guys. 2a times a is going to give us 2a squared. If I do my outers, I'm going to get positive 5a. Inners is going to be positive 2a. And my last is going to be positive 5 times 1 is 5. 9 is going to distribute into my bracket here, so 3 times 9 is going to give us 27a, and 9 times 4 is going to give us 36. Over here, let's FOIL out again. 2 times 3 is 6a. I'm going to have negative 4a plus 9a, which I'm just going to save some space, is going to be 5. Let's just make sure 9 minus 4 is 5, so yes, positive 5a, and minus 12 equals 0. Okay, sure, lots of working out there. All right, but as long as you're just going through it carefully, then you should be fine. Let's look for like terms. I've got a 2a squared plus a 6a squared, which is going to give us 8a squared. 5a plus 2a is 7a. And I have got, what else do we have? I've got a 7 plus another 5. That's going to be 12. And then if I add 27 to that, that is going to be 39. And then finally, we've got like terms here. I've got a plus 5 minus a 36 minus a 12. And I'm going to very quickly just do that over here so I don't make any silly mistakes with it. So we've got a 5, I've got a minus 36, and I've got a minus 12. Okay, so we've got negative 43. Negative 43. Okay, and it's equal to 0. Okay, now guys, it is a case that you're going to have to factorize that left-hand side and follow the steps. Once it is factorized, you're going to take each of your brackets, make it equal to 0, and solve for a. And that is a challenge that I'm going to see if I can get you guys to do, okay? I want you to see if you can solve the rest of that equation, and let Abram and I know if you actually get that answer right. Let's see if we can actually get that one and get on top of it.
Post those answers over the Facebook
Post
page.
those answers on Facebook. Let's see if we can actually factorize that trinomial. It's a bit of a mean one, so let's see if we can get it factorized, okay? All right. Let's see. Do we have time? We do. Okay, we're going to do another one over here quickly and see if we can solve for x. Okay, so now we're going to get you to multitask, because now you have to do the sum I've asked you to do, and you need to listen over here. Okay. We have x squareds in there, guys. Can you see that? We've got x squareds, which immediately says it's a quadratic equation. Okay? So because of that, let's follow our steps. We're going to gather everything over to the left-hand side, and you want that right-hand side to be equal to 0. Okay? So I'm going to have negative x squared plus 4x minus 6, and I'm going to have minus 4x squared plus 14x minus 3 equals 0. Okay, so everything has now been moved to the left-hand side. Now we are going to gather like terms again. So I've got negative x squared minus 4x squared, which is going to give us negative 5x squared. I'm going to have a 4x and a 14x, which is going to give us 18x. And negative 3 minus 6 is minus 9, which is equal to 0. Okay. All right, guys. This over here we don't like. We do not like a negative in the first term over there. And because it's equal to 0, we are allowed to get rid of it. Okay, so what we're going to do is basically pull it out as a common factor, and then we can get rid of it because the right-hand side is equal to 0. Okay, so what it's going to become is 5x squared minus 18x plus 9 equals 0. Okay, let's factorize this one. Factors of 5, I've got 5 times 1, and that's it. Factors of 9 was 9 times 1, or 3 times 3, which I'm going to invert to 1 and 9. There's no point to invert 3 and 3 because it's going to look exactly the same. So we just needed to invert that 1. We were looking for 18 as a middle value over there. So let's see what we can do as a combination. I've got 5 times 3, which gives me 15, and I've got 1 times 3, which gives me 3, and if they were both positive, they will add together to get us 18 in the middle there. Okay, so that works for me. So then let's factorize. Let's remember what we do. We put brackets around the top and brackets around the bottom, and we bracket it, and it's equal to 0. So I've got a 5x, and I've got a 3, I've got a 1x, and I've got a 3, and in this case now they're both positive. So therefore 5x x is equal to negative 3, and x is then equal to negative 3 over 5. Or we've got x plus 3, which was equal to 0. And if I move it over, x is equal to negative 3. All right, and those are the two solutions to that equation. Right, Abram, has anyone surprised us with the answers there yet?
So far, no. They still need some help also in simplifying, and they still say we need more on the fractions. Quadrilateral equations also, we still need more. And if you could please also repeat the last equation.
Okay, well, unfortunately, we're not going to
But
have
the
time
challenge
to
is
do all
still
of
is
that,
on.
guys. So
Yeah.
the best thing to do is go onto the website. I think you can download the video,
notes, yeah,
watch it
also.
again, watch it in your own time, and just take your time to understand it.
Well said on that one. I like what you just said, that guys, the information is out there. You'll get also over the website, which is learnextra.co.za/live. You can also get some links there to our YouTube channel where you can get certain shows that you've missed also. You can still learn more on that. And another one is that up next we'll be having another great one for grade 11's mathematics. It is analytical geometry. Hope you're ready, but thank you very much for everybody that took part into this great one. Hope you've learned a lot. Tamlin, thank you very much.
Thanks
it's been
so much,
awesome.
guys. Thank you.
It's been great. We're still over the page, Facebook /.com Learn Extra. Up next, it is grade 11's. Hope you're all ready, guys. See you on the next show, grade 11's. Thank you.